Hey everybody, I'm Tim Banks. Welcome to me. Join me as, all right, so this is very much a pun. All right, so I need you all to appreciate the pun here. Right. 50 years of SQL. It should have been aging gracefully, but this was just better. This is me, computer nerd, jiu-jitsu zealot. If you get me started talking about jiu-jitsu, that will be the rest of the meetup, just so you know. But if you do want to talk about it instead of this, I don't need the slides. We can just start talking. Good selfies. This is actually a selfie. Take my phone, like with my hand. You can't even see the handout. Like, so if we want to have a meetup later on about how to take selfies that don't look like selfies, we can also do that as well. So let's talk about this. SQL, Structured Query Language. Some people call it SQL, which you can do for some cases. You cannot do it for MySQL because it literally says in the docs it's called MySQL. It's not like, what's that?
Because it's Microsoft.
Well, no, MS SQL, you can call it SQL, but not MySQL. It's not like GIF and GIF, right, where it's not in the docs. But, you know, we think about SQL for a lot of different ways, a lot of different things. Essentially, it's made so you can get data, you can put data into and get data out of a relational database, right? You can also do database management tasks and things like that. Useful tool, but essentially that's what it started out as, is just a tool for being able to put data in and get data out. So it started off as foundations led by Edgar F. Codd's relational model. This is early IBM, early mainframe, stuff like that. Later on in 1974, which is 50 years ago, happy birthday, the Structured English Query Language, SQL, was developed at IBM. Now, so very early, very sharp. It was rough, okay? It was rough, and it was started. And I think it still came out originally on punch cards. So I don't know who's ever written a query and left out a semicolon, but imagine that on a punch card. After that, you got some standardization efforts that got picked up by ANSI and ISO, which is kind of a big deal because then it gets, once it becomes standardized, that allows other people to build on it in a certain way. Things take off that way. You had Oracle. I mentioned it. Is it like $4 a mention? I mentioned it twice, so I think I get 2. It's only $7.75 for mentioning Oracle twice. But they launched the first commercial database. It was RDBMS. Microsoft SQL Server came out, '89. Originally developed in a partnership with Sybase. And I remember this one because we used it when I was in the military, and it was god-awful, right? But eventually it became just awful. But then we go to IBM DB2, SAP HANA, and Sybase SAE. So these are the things that when you think about the financial industry, when you talk about your real-time stock trades, your bank financial transactions, stuff like that happens, those are all built on these, right? And this is kind of what was really the start of fintech, as we know it now, started back here because of these high-performance, scalable relational databases, right? They had locking transactions, they had atomicity as a concept that really made it, and they could keep up with the transactions that were happening that were done by paper. Now, done by paper, done by database seems like magic. Nowadays, it would be super, super slow, but consider the fact that you used to have to like write a trade down and hand it to somebody. Somebody would put it in a ledger and then read it back hours later. This was magic to them. So let's talk about open source. I mentioned a bunch of commercial stuff. MySQL, right? Was the one of the first open source relational database management systems. How many people here started their career on LAMP stacks? All right, make sure you get your colon checked, y'all. I also started my career on LAMP stacks way back in the day. And then this other one that all the nerds came out was Postgres, which is really weird. I never heard of it. No one used it, but some people wanted it, so we used it. Postgres, I feel like, probably the winner of this one now. Not necessarily because Oracle, is that $12 now? Bought MySQL, but you know, I feel like it's become the standard now for the open source relational databases. So let's talk about cloud and big data. Distributed storage like Hadoop and Spark, right, allowed us to really get a lot of querying of huge data sets, batches for Hadoop, real time for Spark. But the way that it was distributed and sharded and stuff like that allowed you to query large sets of data with single queries, and it would just take some time, right? Also, we have flat tabular files and almost limitless, seemingly limitless, but not but certainly sometimes cost restrictive. Object stores that the hyperscalers can make accessible to you. So you've got things like Athena, God help you if you have to use that, Snowflake, BigQuery, and things like that that allow you to just take big flat files that are laid out in certain formats, and you can query them using SQL. All right, DBA. Who here has ever been a DBA? Who here is still currently a DBA? All right, what system?
Redshift and MySQL. So they're both hosted in the cloud, though.
Yeah. Do you need a drink right now? I know it's supposed to be dry, but.
Hi. We need air.
Okay. But yeah, you've got Amazon RDS, Cloud SQL, and Azure SQL Database. A lot of these managed services took kind of like the heavy lifting of deploying databases and maintaining databases, and unfortunately, a lot of times having an actual database administrator on staff. Now, your mileage may vary with not having a DBA. Folks that still need high performance still should use a DBA on these, but you don't necessarily have to. Okay, let's talk about NoSQL. See, that was a really, I really didn't appreciate, right, the NoSQL flipping the tables, right, that was good. So as we know, some workloads, especially as they get more distributed, and the types of data you put in there don't necessarily lend themselves to having a relational data store. It's awkward, sometimes it's cumbersome, it's more than you need. You got scalability, resilience issues that at the time were more difficult with relational databases when some of these NoSQL databases came out. But obviously there's been progression, but still there's still a good use case we made for several of them, right? You've got a few types. You've got a document store. MongoDB is a great example, 2009. My last DBA job was as a MongoDB database administrator, which is why my beard is gray. Come on, that was funny.
Your web's go.
Yeah, as long as you didn't care about keeping your data. Right? Cassandra was developed by Facebook, wide column restore data, and a lot of work from DataStax, if anybody's from here, to bring it really up to the forefront. And then Neo4j graph database developed in 2007. Three examples of types of NoSQL databases that have very defined use cases and are very useful even today. So let's talk about the future of SQL, right? Computers are much faster, storage is much cheaper and more distributed when they first came out in the Cold War, right? So now, what does SQL look like in this day and age? Well, you've got new data source types, JSON, XML, spatial, other data like that. You've got hybrid SQL, NoSQL systems. Sometimes you've got like the document store engine for Postgres and things like that. You've got Amazon Aurora, which is a good example of having an SQL database on a document backend. And then you've got adoption of more API-based interactions versus just using an SQL query to query a database. Now you have more APIs that let you do it a little bit differently than you had before. We have to mention AI ML. I think we all get paid for that, right? If I mention AI ML. Okay. But no, there's AI ML that are doing maintenance and optimization, especially as we have now container-based stateful workloads that will shift things around when they need to, so you don't have to actually intervene, or they'll do optimization tasks and things like that. And there are more hooks being able to built into them for other both managed services and self-hosted and self-managed database engines. You also starting to have the integration of machine learning algorithms directly into the database engine, which makes it a lot easier for folks to use. You kind of skip you can skip a layer of abstraction when you're trying to deal with these things, and it makes it more performant. I hate that word, but I just used it, so I'm so sorry. So, happy 50th SQL. At least you're older than me by 1 year, but it's enough. So I think that was the end of my slide. Yeah, that was it. So if anybody has any questions for me about 50 years of SQL? Yeah.
I don't know if it's a typo or a Freudian slip, but you said you were Mongo DBA.
Yeah.
It's spelled Mongod.
Oh, yeah. Probably more Freudian, to be honest. Yeah.
This is a history lesson. There's a lot of newer tools. Do you see SQL still being a language that's relevant in the future as data systems become more and more sophisticated?
Absolutely, because a lot of the stuff we do now is based on very large data sets, right? No one gets rid of old data anymore, and they certainly don't retire old data stores for some reason. So we will continue to have SQL and SQL data stores and people who need to write SQL, read SQL, et cetera, literally until probably, you know, I don't know, the cows come home in a very like, you know, whenever that is. No, I can't see it going anywhere. And then people, oh, you know, it's going to go away. And I was like, okay, well, just like Fortran and COBOL went away, and they haven't. Yeah. So I don't think it will ever become irrelevant. I think how we interact with it and how those data stores get used is going to change, but I think it's going to be an evolution of SQL versus whatever comes next after that.
Is there a competing language that is rivaling SQL for accessing these large data?
A specific language, I would say no. I wouldn't say that one really that has materialized it yet, but I will say there's a lot of API and abstraction layers that are coming out or are in use now that if we could sit on one standardization and have good backing on it, probably. I don't know what that is right now, but I wouldn't say that it's out of the realm of possibility for sure.
Yeah.
I think your answer about Snowflake and Athena is what you're talking about is the answer.
Yeah.
Keep throwing everything in and then write SQL on top of horrible data sets.
Yeah. Yeah. Don't.
Just vacuum it up and just throw it away.
Literally, yeah.
So that you were saying like 2009, 2008, and I remember going to Day-to-Day Texas in 2011 or 12, where like, what's his name got together the best minds in data business, and you have people talking about, you know, Hadoop is a thing, it's there. Cassandra's a thing, it's there, it's out, it's being used. And people are continually asking the question, so how do I use SQL to work with this data? and you know, the minds are saying, why? We've given you this great tool that lets you do it faster and better. And 2 years later, everybody has a SQL.
Well, I mean, the funny part was, I remember, was that? Exactly. Well, it's like I remember everyone was like, "Yeah, Elasticsearch is so great. Can we talk SQL to it?" And they're like, "No." And then like 3 years later, it's like now you can talk SQL to Elasticsearch. So it is inevitable. It's like, you know, like yeah, eventually any vehicle is gonna get, you know, a tow hitch with something hanging off the back of it. You know, Cybertruck. I've seen one now. It's already like. Yeah, what you got?
We've been working on natural query language since the late 1960s. Started back with Pig.
Yeah.
And if you think about what's happened with the AI, you can easily see how the AI is going to evolve even SQL into a more natural query language for the uninitiated.
Yeah.
For those that are still having to crunch the big numbers, you're going to be stuck with something like SQL and the API language going forward. Because, like you said, COBOL, Fortran, C, we're stuck with them.
Yeah. All those back-end data stores that these things are being modeled off, they still speak SQL. So you'll have basically an AI, you know, natural query language, large language model that acts as a front end for an SQL backend. And like I said, it will probably never ever go away.
I mean, one of the things that's great about SQL is its longevity.
Yeah.
IBM put a lot of work in to make something so that office assistants in the 1950s could write data queries.
Yeah.
And that level of abstraction is super useful even to this day.
Mm-hmm. I agree, and it's a lot of forethought, and obviously it didn't happen all at once, but the concept was laid down, and we iterated on, improved it, iterated on, improved it. So, any other questions, comments, concerns? Anybody have any questions about jujitsu?
You're going to tank the night already?
What was that? Okay, yeah, sounds good, sounds good. Well, that's it. That's for me. I've been Tim Banks, and thank you very much.
Yay. I feel like this is a really good one to follow up on in the fact that I started learning about data infrastructure about 14 months ago. I started coding almost a year and a half ago. So this has been a very interesting adventure. And also the fact that everything that Tim just went through, I learned a lot of it while going to the Computer History Museum at Google Cloud Next back in I think that was September. So it's been a whirlwind of information. If you're like, oh, hey, there's SQL, there's Kafka, there's event streaming, there's also Flink, Cassandra, there's Influx, Mongo, M3. There's so many different ones. They're like, if on the top of your head, how many databases do you think your company uses on a daily basis? Or
Probably easier to count them on DW.
okay.
All of them probably?
All of them all at once. Okay.
Are we going to count the people who use Excel as
Well, so maybe.
Key values surrounding database.
Because,
But they try.
Does SQL like count? I'm firm believer that big data
Yes,
is
it
anything
does.
that doesn't fit in Excel.
okay. Well, that's kind of where I'm coming from with learning about Kafka. And do y'all say Kafka or Kafka?
Kafka.
Okay, because I've noticed it really matters where I'm at, and I go with both.
I think it's England that says Kafka.
I don't know. Like, I always ask people, and then I go, I don't remember which one does what. I just go with both.
Just say it the southern way, and then the northerners will come back and tell you to say it. So just go with it.
It is a really good opener, though. How do you say it, Kafka or Kafka? You know, at least you guys respond to me. As we went through a whole bunch of open source stuff a minute ago, I feel like I don't need to go through this slide, which is easy. Yay. But, oh, my slide went away. Well, that's all, folks.
Hey, let's go.
Oh, well, hold on. Where'd it go? Did I delete it? That would be kind of funny.
Oh, no, they just got the bottom.
Okay, we're just going to move this slide back up. Hold on. Okay. So we are going to see, yay! So when I think about Kafka and I think about databases, if I'm just like a super noob, which I still kind of am, I'm thinking about that when I go into, you asked about Excel, when I go into Excel or Google Docs or anything like that, I'm like, okay, my name is Jen. It's Jen with 2 N's. And autocorrect always puts 1 N. It is very, very frustrating. So on a regular SQL database, you can go in and edit it. And then I can fix it, and it'll say Jen with 2 N's. And voila, it's fixed. Kafka is a little different. Kafka does logs. So no matter what, these logs are not going away. So if I want to go in and say autocorrect went in and did Jen with 1 N, it's going to be a history of every event, every log, every time something happens, and show that it was Jen with 1 N and somebody put in Jen with 2 N's. So it'll take a history of all of that. And when we do that, we create topics. Woo. So we can have where everything goes into, if you think about like, who here uses Reddit? Okay, just for pure curiosity lunch conversation, who uses Stack Overflow? Okay, ChatGPT. All right. I also asked Twitter a lot of questions, so thank you for the conversation. When you're thinking about a topic, if you think something like Reddit, you have all of the topics there. You can have subreddits, you have different ways of thinking of things. That's kind of how Kafka organizes their topics. And when we go to write an event or a log, like my name is Jen with 1 N or my name is Jen with 2 N's, I produce the content. That's what happens, and it will go all into the topic. And that's a twitchy screen. That's fun. And it'll create all the different logs within a topic. So it knows that I did it with 1 N and then 2 N's later on. But then we have the consumer. And consumers can happen in many different ways. That you can have it where the consumer only consumes certain information. You can also add information and then add it to the consumer that we had. Or we can have more than one consumer. Meaning that like if I'm consuming the information from my iPhone, my iPad, my MacBook, all of that, those can all be different consumers all together, and I can tell them which ones to take the information. So I can tell it to do all of the events from the very beginning, like the laptop, or I can do it for only certain information and tell it from all times, certain times, or only partial times. And that in a very, very quick overview is what Kafka does. The bare basics of Kafka. Yay, I'm done. I think it was 5 minutes, I hope. And thanks everybody for being so kind.
I have far too much content.
I'm gonna take your seat, though.
I will try to go over it as quickly as I can. This is 2 years supporting data science at Hard Rock Digital. So what we did with the green field. So we had nothing, nothing built out at all. There was a team of data scientists who had basically no embedded ops person. There was an architect who I quite respect and love to work with. His name is Joe Rizzo. If you ever meet him out in town, say hi, he's great. But he didn't have the time to build out their stuff, so I ended up taking that on. So this is who I am. I'm the lead SRE at Hard Rock Digital, and I'm the accidental backseat architect for our data science team. First day on the job, I show up, one of their project managers comes up to me and says, hey, we need to deploy this service. And I say, what? I'm here. I've been here for 2 hours. That's okay, I've worked with these folks before, I know them. What do we do? Hard Rock Digital is the sports betting casino wing of the Hard Rock brand. So what does our data science team do? They do, it's like the stock market, but for sports. So what they do is they do bet enrichment, so adding extra data to bets, personalization, so this is like, hey, maybe deposit less money or more money. They do experiments on our user base and other data sciencey things like enrich our backend reports, tell us how much money we make or lose, those sorts of things. What does DevOps do with our data teams in order to enable them? Patterns, patterns, patterns. What we do is we set out what is a good thing to do, what is a bad thing to do. I write their deployment tooling. I help them write all their Helm charts, which case operators to use, how to monitor their services, all of their pipelines, how not to spend lots of money. This one's important. People ask about that a lot once you get rolling. Networking and support, data storage, and security. All that stuff falls under sort of what our SRE team does, what we do for the data team. Tools we use. Yes. I'm not going to read this slide because yes, we use all of them. Of note to the folks that are here, dbt, Airflow, Databricks, Confluence. Yes, we do use Snowflake. Snowflake's very cool. I like using it. In terms of the infrastructure side, Terraform, the Grafana stack, Prometheus. Yeah, those are interesting ones. I'm going to talk about GitHub in a bit. So what are the goals for them? Right? What we want to do is we want to set out how to create patterns that remove barriers to production. Oftentimes, data science gets siloed off in like, hey, we made a report. That report has been given to data analysts. Those analysts then go to the C-levels to make a slide deck. You don't want to do data science like that. You want to affect the products you're working on. You want to say, hey, we noticed a trend in our behaviors. We've actioned that trend into a performance enrichment. We then want to push that back into the product, right? We want to create an API the product can use to do something fun and cool. That's what we're really trying to enable as DevOps people. We don't want to build the next best Tableau server. We've all done this. What we want to do is actually take data science work and put it in front of customers. So what are we trying to do? We're trying to encourage a fast iterative process, a culture of ownership, a culture of monitoring, right? Make sure that users are running their own applications, that they're owning those applications, that they're viewing them, right? Just like any product, we want to treat them like they are product owners, because they are. So what are the fundamentals? Separations of spheres. Make sure that when you are working with your data science team, they have their own space to play in. Do not make them share with other people. It's not worth it. So we're in a compliance-heavy regime, right? We're in sports betting. That means we have lots of compliance things to deal with. Let's say that you work with HIPAA. Let's say that you work with something else. Figure out a way to find the border on what data is something that you can work on iteratively and fast, and what is maybe not so iterative and fast, right? What is compliance-heavy that needs to be overseen? What is the stuff that is productizable that you can do quickly? And once you find that border, start really drawing everything out from there. It helps a lot with productizing. Data science is often really slow moving from a tools perspective. These folks, they're not often Git specialists, right? Like we're not hiring them because they know how to use version control. We're hiring them because they're smarter at other different things. Structured data storage stuff so that it's easy for people to work with, right? If you're working with RDS, don't make it super hard to get to their database, right? You're looking to build easy tools that smart people can deal with. And then, of course, procedure and process, right? So when they're often committing into version control if we're all doing things correctly. Make sure that you are putting in flows so things are safe and good. One of our big pain points was that we had a team that was hauled off with no oversight, and they built the most bad way of handling code inside of version control that we are still unwinding to this day. Good fundamentals means better product. All right. Oh, God. Yeah, I want to see what do we got. Way too much.
You can keep going. We got time.
Okay. So things.
I sped mine through mine as quickly as spot
Yeah.
to give you the most time possible.
Oh, thank you. Things we did well. Things we did well, Helm charts, Git templates, and ownership. We really knocked that out of the park, right? Immediately, first thing I did is I gave them their own Helm templates. I gave them ways in which to monitor their own stuff. I said, here's how you do it. Here's the good patterns. Go nuts. And to this day, I don't really have to do much there. They pretty much own all of it. They were early adopters on a lot of the practices that we then brought to the rest of the organization because I used them as guinea pigs because they were so good at this. It was great. They also own most of their own infrastructure. I don't write Terraform for them anymore. They write their own. It's wonderful. Make Git less magic. Use actions. Use branching patterns. Encourage PR flows. Encourage PR flows. I cannot state this enough. And that means that you as a ops practitioner or as somebody who's getting involved in this, use code owners. Use integration tests. Put in documentation from the outset of a repo. Don't do it after the fact. Do it up front. You will thank me later. You've got a lot of boilerplate for some kind of project type. Just make a Git template. Put all of the template code in that template and clone the thing over and over again. Try not to make it hard on yourself. All right, Helm and Cates, right? Choose the right organization patterns for your needs. People are going to argue, do we do a monorepo? Do we do distributed charts? Doesn't matter. It's whatever your teams need, right? Your teams will end up supporting this. Maybe they have a lot of linked code that is shared libraries. Maybe it's a monorepo. Maybe they don't. Maybe it's a lot of little microservices that are all very unique and it's all a bunch of distributed charts. Take your pick, right? There's no real wrong answer here. The wrong answer is what inhibits your ability to deploy to production. Charts should be regular. Don't make things unique. You will pay for it later. Once you hit levels of complexity that require you do things, use operators. Operators are good. They are your friend. Oftentimes when you're working with Helm, you think like, maybe if I just add this extra case statement, it'll be good. Just write the code, right? Go write an operator. Find someone to write an operator. It is worth it. Right now, we're paying for this because we haven't sat down to do that, and we have so much regular code. And don't make people do stuff that an operator does. Permissions, RBAC, monitoring, routing, DNS, any of these things, right? There are operators already written for you that do this really easily. Use them. Monitoring. So here's some example of this is stuff that I didn't have to write. My data scientist did it for me. Again, build it in. Make it easy. Don't make it hard. Make it so that whenever they submit their application, it just comes in. Have them define it. Because you don't know, as if you're doing what I do right at SRE, you don't know how their experiment success metrics are supposed to work, right? I don't know what it means that this middleware deposit application had a slow duration. I don't know what that means. They do, and they tell me what it means when it goes bad, right? All I say is hey, did you write an alert for this? And they say yes, and I say great. Is your service working well? Well, the alert didn't go off. Great, right? So easy to learn on, easy to contribute to. This is important. Make it so that all they have to do is deploy their application. Really, there's so many operators that support this. That is, don't make it an extra step. Make it something that is part of just normal acceptance. If you're going into an integration environment, it should be there from the outset. A lot of you probably heard this, especially if you've been in the DevOps circle, so I will not, I won't harp on it too much more. Infrastructure. Unfortunately, meetings. You are going to need to meet with these people. You're going to need to know what they need. You are going to need to do it regularly. One of our big failings is that I only met with my data team once every 3 weeks at the start. I had to actually start attending all of their grooming sessions and going to all of their stand-ups to actually get this thing really nailed down. Plan on it. Just embed. Embed soon. Try to do it. It will help you. You won't have to do it forever, but it's good if you do. Make adoption seamless. I already talked about a lot, a recurring theme in these slides. And then easy ways to implement complex business patterns. I already talked about that. Things that we failed at. We weren't embedded enough, right? So why did I talk about this? It's because I struggled and my team struggled to support our data team because we did not spend enough time with them. With Snowflake, we basically could not get ahead of their team's development in order to manage it with IAC. Huge pain point. We're still paying that down today. Rundeck, Confluent, DBT, all of these have basically the same pains of poor usage because we could not integrate fast enough with the team in order to get a good pattern in place. So patterns naturally occurred, mostly from yours truly, and they were bad. They were not good patterns. DBT in particular is a very weird one. Involves a lot of doing Git right. So you've got a bunch of SQL code. You need to make sure that it's all integrated correctly into a main branch as soon as you can because it will get out out of hand. And then this one is the alerting stream. A lot of you probably use Slack or some sort of internal alerting, like internal chat tool. This happened to me, and I made it, and it was a bad idea. That is 15 different Slack channels that all do alerts.
You should absolutely feel bad for that. That's awful.
There's more than that.
It's also come as requests from other people.
Yes, yeah, but long story short, think about how you're going to tell your developers when things go wrong. Really give that some thought. Like just sit down with some whiskey or something and really plot that sucker out, because it's going to come up, you're going to have to do it anyways, and if you don't think about it, that happens. And then Airflow. Right now, I'm fighting this battle right now. There's a ton of ways to run Airflow. There's like 6 different ways to run Airflow. It's a really complicated service to use. DAGs aren't easy to read or understand. Really think about not just how you are putting DAGs in the DAG bag and what you're doing in your VCS, but also how you're running this thing. So we use managed Airflow for a while in AWS. We've run on-prem Airflow. Right now we're looking at Astronomer. Like there's a lot of different ways to run this tool, and a lot of you are probably using it to do some sort of like basic convenience coding thing. Actually, show of hands, who's using Airflow in here? Yeah, for those of you who are using it, right? It's complicated. You think about it, because it's caused me a lot of suffering, and AWS managed Airflow sucks. Thank you. Questions? Yes.
So I feel like, especially when it comes to like infrastructure, one of the main problems with data science teams is they essentially set money on fire. How do you go about it with your in your feedback and monitoring? How do you go about giving feedback to them, either from the outset or as a kind of a retrospective, like, hey, this decision is costing us a lot of money, and getting them to like be aware of that in a not business crippling way.
Right. So what was it? There's 2 kinds of problems in business problems and problems. First, identify if the spend is okay. Sometimes they want the company just wants to spend $2 million on Snowflake annually because they want to. Right? Like you just can't stop them. But when it comes to actually building a cost optimization, what I found is that it's always a question of like, is the problem you're solving worth the amount of money you are spending on it? So if you can conceptualize how expensive a problem is, that's usually the great way that you can convince business leadership to be like, hey, maybe we pull that back in, we reel that spend back in. Oftentimes with data science teams, I find that on the low side of reports generation, business data management, the cost is really, the cost appetite is very high. As long as the reports are flowing to their analysts and to all the C-levels and everybody on their slide decks, every hour on the hour, they're really happy. Like they don't want to touch that system because it's working. But what I find with the product stuff, I do get to, like that's where you do get to come in and say, no, you don't get 150 cores in the cluster. Like, no, you don't get to do that. Figure out how to be more threat efficient. And that's where I get to like, because I have to do that with my data science teams a lot actually. It's like, oh, we have to consume this, this queue that's going to build up to 8 million, 8 million objects with a 24-hour consumer lag. If I don't deploy 150 cores right now,
You want to export 150 terabytes of
what to where across my network? Because you do pay for that too. And so yeah, it's really more of an efficiency question, right? If you can say it's like, look, you're going to cost me this. It's going to cost me this much money in hours to solve just that job. Is there something else we can do to reduce that core count? Like, is there some other resource that I can give you? What's the, I'll horse swap with you is a lot of how I end up doing it. Is that like, it's like, okay, like you can spend that, but what is it that we're going to do to make sure it doesn't happen? Because oftentimes, it's coming in like as you need it, right? The business needs it.
Yes. Have you had luck? Have you tried exposing costs to them through the monitoring tools that you're talking about?
We are trying. We have cube cost on some of our clusters. We're trying to get it as a standard thing, but it's slow going.
Do you at least give? I'm sorry, just one last. Do you at least give them feedback based on their like CUR files or invoices or anything like that?
Yes, yeah. We look at all the granular account based. So one of the other reasons why you do you separate out the accounts as soon as you can. Costing streams, one costing stream per team, very nice, very helpful. Yes.
Did you have any issues? So you talked about putting the Helm charts and a number of the IAC in the hands of the data scientists. Did you have any trouble getting them to adopt owning those practices, or was that pretty seamless?
Yes and no. So yes, once there was enough trust built up in how Helm Kubernetes functions or Terraform functions, it was very easy, right? So the why I stressed on patterns is because people crave regular things, right? And so when it was uncertain and they were not sure how it would behave, they would come to me a lot and say, hey, this thing's broken, I don't know what I did. I looked at it wrong, I put values in, I don't know why I won't deploy, I don't know what's going on. And that's when I got I had to do a lot of hand holding, a lot of it's okay, here's what I did, here's my change, here it is in a PR, you can take a look at it. And that's why, so when you are working on those things, you work alongside them, right? Don't come in as God and drop I have made the fix and it now works, right? Try to make sure that it's in public, that they can see it, that they can learn from it too, because that's how they're going to end up managing it without you anyways, right? Goal here is that you go to Hawaii on a vacation and lose your phone in the ocean, and they're still running data science experiments without you. So that's, at least for Helm, that was very much true. Terraform is a little different. I find that you actually have to have an infrastructure bend to you to really enjoy using that tool in any way, shape, or form. So, tolerate. I don't enjoy using Terraform either. But in order to do things with it, right, you have to kind of understand what it's trying to do, how it's trying to do its thing. I find that really simple tasks like I need an IAM role, they're great at that. More complex stuff like I need an RDS instance that has the IAM role configured and it has to have maintenance, right? Once you get past 5 or 10 variables, they're I don't know. You should write this for me, which is fair. I think that ultimately be honest with yourself about how the level of contribution that these folks are going to have into your various pieces. Don't remember that it's always going to be a social task to actually get them interested and involved in that kind of development. And it's never, unless it's required by the business, it's incumbent upon you to sell it to them. So, you can't just lay it down as you have to do this. It really does have to be if you want to do your stuff faster and without me, this is what you need to do. And so selling it to them is an important part. All right.
Thanks.
Thanks all.
Clear, Ben, I was clapping at that last sentence.
Oh.
Yeah. I was I don't think they're done with questions, but.
The hook I was trying to scratch your back. I wasn't trying to pull you off stage.
No.
Okay, did this live? No, it didn't. Okay, so we're just gonna do this. And then go here.
Sorry.
No, I'm talking to the computer, not to you guys, sorry.
At my past 2 jobs, the 3, my primary contribution has been to walk onto a team that's at least somewhat dysfunctional, and the relationship with the people who are asking them for help, resources, whatever, is entirely dysfunctional. And it's all about what the last things that you said, publicizing the interface with the team. What is it that we provide? How can you get it from us faster and without us being the roadblock? And how can this team that has been, a hostile entity to you, whoever it is, data science teams, how can we be an enabler for you? And each of us gets to be the grumpy gusses that we are on our own time.
Yeah, I mean, that was, so, I didn't really talk about it, but I also spearheaded the adoption of Terraform in my organization, and it was really my project that it was, it went from, we had a couple loose pieces to we're gonna have a standard, this is how we're gonna do it, this is how, we're all gonna write this stuff. And we were all in agreement beforehand, but nobody had dropped in the actual investment of architecting.
Yeah.
And the biggest pain point that I had was how hard it is to build a standard, promulgate that standard, and then make it consistent. There were lots of internal holy wars about what is consistency mean? What does it mean to do this here? Most of them have died down. They are mostly to bed at this moment. There are still things that I wish I could undo, but a lot of it was just, all right, we need to do this. How are we going to achieve it? And how do we make it easy for the folks who show up? What are the easy handholds? And I do think of it as like easy handholds. Like I'm not trying to make experts. I'm just trying to make people who know how to fill out forms.
I'm so shocked to hear that engineers had arguments about standards. I mean, after all, like if everyone's always like, you think of something easy and simple like a naming standard. Whoever argues about that.
Oh, who has ever bike shitted? Certainly not me.
I want Lord of the Rings. I want Marvel.
So I missed, and if we didn't do it, who sits on the data science side in their org? For real, Eric? Yeah?
That's it?
No way, buddy. Okay, cool.
I have in the past.
Yeah,
But gloriously do not know.
interesting.
I'm an embedded SRE on data science.
Yeah.
Doing God's work.
Basically, alerts just go to L2, and then L2 just escalates it right back to the data science team.
It's optimized workflow. Well done.
I read your run book. I could not access the resource. It's yours now.
So
Is it idea sharing?
Does that mean we get a hand it off?
that was the plan. Yeah.
I know, but I was making sure you guys were done with the conversation.
That was the
I mean, I
plan.
can talk, but I know all of you can talk, and especially about this stuff. So, and talking about that, it's your turn.
So who came with a thing that they wanted to get out of this that they feel they didn't get so far? It's cool, to be honest. I wanted more pie, but there was just cakes of pie.
Can I pitch a little something that we're working on? That's gonna be real cool.
What was that?
I had a question just for you, Jen, about Kafka specifically. Because you mentioned you started, and you said, hey, I want to work on, you've been a developer 14 or 15 months.
Yeah.
And you said, let's choose the most complicated tool that could possibly in space. So,
Yeah.
I've been using Kafka for about 5 years now.
Okay.
I kind of was like, okay, I want a tool. It's kind of what everyone is using in Fortune 100 companies. So why did you choose that? What was the problem you were trying to solve, I guess? And then what's the scalability? Because it has infinite scalability, essentially. So what problem were you, or you just said, I just want to pick the most complicated problem?
Fair enough, fair enough. So the way I ended up doing that is, so I actually worked for a startup here in Austin called Stoplight. And in January 2022, I was let go. And I was like, I don't know what I'm gonna do. I'm just gonna focus on my podcast called Shit You Don't Wanna Talk About. Wonderful podcast, you guys should all go check it out. We talk about really tough topics and I'm launching a new season. But that was not very money-making. And I did that trying to figure out how to make money doing that for 6 months. And I was living in Denver at the time, and the Denver API Meetup was like, yo, Jen, you should become a co-organizer. And I was like, cool. I don't like APIs that much, but okay. And so they were like, have you ever heard of developer advocacy? I'm like, what's that? And they're like, yo, you get to talk to people and advocate for developers, and it's like what you want to do like with your podcast, but like for developers and help the community. And I was like, oh, that's cool. So I found Twitter. I'd never used Twitter before. Like, I think I had like 3 followers at the time. And somebody posted, hey, if you are in DevRel or developer advocacy, post here so people can reach out. And I was like, okay. I linked in this person and said, hey, can I reply to your tweet? Not knowing it. And this guy's like, yeah, that's what it's there for. So I reached out to every single person replying to each tweet saying, hey, can I set up time with you, please? And they're like, dude, DM me, duh. So I did, and the first person I met, his name's Wesley Faulkner, and he is such a dope soul. And he was like, yo, dude, you have the personality, you just need content and know the tech. And I was like, cool, okay. The next person, Ramon, who is Ola Soy Milk on Twitter, was like, yo, dude, I'll peer program with you. What's that? It's where you go and code with each other. Okay, that's cool, that's a thing. Then the next one was, his name's Anthony Campolo, and he was in Web3. And he's like, I'm so down to teach you some stuff as long as you promise not to go into Web3. Do not touch it. Do not touch it. And I was like, okay, cool. So this is mid-June, and July 1st, I was like, I'm going to start a show called Teach Gen Tech. And that's a very long explanation to say I didn't know what the hell I was doing. My very first episode, didn't know the difference between HTML, CSS, or JavaScript. And I did 5 episodes a week from July to October. And there was this big account that followed me, Maddie Stratton. And I was like, oh my God, there's somebody really big account following me. I don't know who this is, but there's somebody following me. And I'm like, okay. And I posted that I was looking for a job. And Maddie's like, dude, you should apply. And I'm like, what's Aiven? And I'm pretty sure I said avian, like so many others do. And we got on the phone. He explained a bit more. I applied, and I got an interview. This was crazy. I have no idea what data is. And then I did my first post for them, and I was trying to make an app and didn't really understand and wrote a blog, and I was like, data's really cool. I like data. I like it so much more than APIs, which I have a former colleague here who actually taught me about APIs, and thank you very much, that he calls me out that we use APIs for everything. Yes, we do. They are very needed in life, but it never clicked. And then come February, I got started almost a year ago today at Aiven. Didn't know what I was doing still. Fast forward almost a year to reInvent at the end of November. And they were like, cool, Jen, you've been kind of doing Postgres, you've been kind of doing MySQL, but you went to Current, which is Confluent's big Kafka conference, and they were like, yo, dude, you got to learn Kafka because everybody got promoted. I was like, that's cool because it is most complicated and seems way more interesting than SQL. No offense, everybody. But yeah, that is my very long, short story of how I ended up with Kafka and am doing my first really big tech talk at PyCon. Because we're going to talk about event streaming and fast API with Kafka. About tacos. Get it? Talk about tacos? Yeah.
So many road feedback to Confluent. We're a big Confluent customer as well.
I mean, you check out Aiven. I will get back to you on all the differences, though, because I'm not sure yet. But that is how I ended up with Kafka, and I found it really interesting because it's really hard to explain these really complicated tech topics to people that are new to it. Like, I got into it, and I didn't know the differences, and okay, just raise a hand, curiosity. How many people know JavaScript? Okay. Do you know how many frameworks there are?
All of them. Stars in the sky.
And meta frameworks? And then you have TypeScript. And then you go like, yeah. And then you start to learn data and databases and stuff, and there's a million of those. We talked about that. But then it's like, oh, like a lot of people use Java with Kafka. But they also use a lot of Python, but not a ton of JavaScript. And it's like, oh, so I gotta go learn Python. Okay, cool. At least I know a little bit about it.
Whoever use Java with Kafka really hate themselves.
We do hate ourselves.
So you know what? Let's use Java and let's use Logstash, but with Zookeeper.
And I'm learning all about that stuff. It's gonna be super fun.
Okay, words hurt.
And yeah.
Sorry, whenever you're done, I had a question for the...
Yeah, ask the crowd.
So, I was laid off a few months ago, and I had time on my hands, and one of the projects that I'm really excited about, because I see a lot of commercial products adopting it, is Apache Iceberg. Is there anyone here who's working with Apache Iceberg? Is anyone familiar with Apache Iceberg? A little bit?
Iceberg is a, if you think about, is anybody familiar with Parquet? The
Parquet?
Yeah. So Parquet. Right. So Parquet does not. So Parquet is one of the basic storage format. It doesn't provide a lot of things. It's just lots of files out there. You keep adding to it, overrides, and you don't really modify each. And to provide, it doesn't provide you transactional control or write conflict, read-write basic, all the things that SQL database provides you, you get none of that in most big data storage systems. So there are three competing formats out there. There's a Delta Lake, that by Databricks. There's Apache Hudi, and then there's the Iceberg. I think Hudi and Iceberg, one came from LinkedIn or Facebook, I don't remember. One came from Netflix. Basically, they are the format that allow you to have asset transaction layer on top of Arcade.
Yep.
And then make you treat them as if you were writing to a database. You can have upserts, inserts, update, and then vacuum sort of thing. Basically, make your big data storage backend feels more like a database server, but without actually having a database server, and you can scale it a lot more.
How does that work, like, operationally, like rate of change wise?
So it's like a big, mostly you work with a not necessarily Hadoop, but big data system. Spark is normally you would use it.
Looks like
You're unlike a traditional database server. If you think about data storage, database, it's a storage plus compute. Whereas big data is storage away from compute. And in these meta storage format, effectively have your processing of transaction on your compute layer. Because prior to this, you have storage away from compute, but nothing here guarantees a transaction, where now a additional layer added at your compute as a low level layer right before it reaches the data storage layer, so that it processes transactions, so that your Spark cluster that have to running the job, running however many worker, have a cooperative cooperation in terms of writing data, make sure nothing is overwriting, and you can also have two different jobs writing to the same Delta, Hudi, or Iceberg location, and they will figure out how not to overstep onto each other. Because if you ever try to have a two job writes to the same Parquet location, you might as well call it dumb.
Would you be interested in giving a talk on this on the next one? Because I would like to get
Yes.
I guess.
We're using a distributed data store right now, but a lot
Okay.
of the time, like, it's like you stick consensus protocols or wrap protocols on top of your data storage layer, and then you basically try to figure out ways to not just avoid it, right?
Right.
You're like, it's like, oh, how do I put all of my fast access stuff away from my consensus protocol, so
Right.
that way I never have to look at it, right? And
Well-
this seems like it's kind of a way to do that without necessarily having to interact with like graph, which I like.
Yeah, but it's not going to be fast access. These are, you're talking about Hadoop style processing, and normally the data we deal with go from somewhere to 100 gigs, hundreds gig, all the way to the largest data set we dealt that we actually tracked. We didn't realize how big it was, 32 terabytes in 4 hours. And those are sort of the data that you're not talking about transaction like seconds, milliseconds. You're not even talking about tenths of a second. You're talking about hours. I'm running this job against 30 terabytes of data, and I want to be done in X hours.
Yeah, okay, so my background is I did a bunch of geodata stuff back in the day, and I think about computing pyramids, right? It's kind of this thing of like, I have a huge data store that I'm normalizing up into a transaction layer at the very top. So
Right.
you're talking about the bottom of
I think sometimes a transaction layer is already handled. You're getting output of that and putting them into Parquet files, things like that, and then doing analytic workloads against that.
Yeah.
So there's like the analytic workloads versus the transactional. Transactional stuff's really fast. Analytic workload, they're taking it from bronze to gold or silver to gold. And
So
all those transactional.
exactly. So all the transactions, especially like you talked about Kafka. Kafka is another series of transactions, but all of that eventually wants to be reported on. And so Parquet, OCR, columnar format, great for reporting, but hard to manage the transaction integrity. So
Right. It's not necessarily says hard the columnar format. It's just most columnar storage format don't have a database server like relational database.
Right.
Because most columnar format, they just lay them out there and let it write. Whereas normally relational database, you have this server sits in front of your data and then everybody access through it.
Or you have something like Snowflake, which is doing that managed for you. So behind the scenes,
Right.
Snowflake has separate data from its compute.
Yeah.
And this is where Iceberg is why Iceberg is getting the attention it's getting is when you are using something like Snowflake, you don't have control and have access directly to the S3 buckets or the files itself. You have to go through Snowflake's interface in order to get access to that data. But because Apache Iceberg is getting so much adoption and it is getting pushed, Snowflake is adopting it as a standard, so you can use Snowflake Compute to query Apache Iceberg data sets. Right. Which also means you can have control over your data, know what S3 file it's in, know what iterations you're doing. Whatever compute you're using, maybe you have a team that's writing Spark jobs, maybe you have an analytics team that's using Snowflake. Dremio is another really cool tool where you can just launch compute on its own and it can touch. But the idea that you have all these different compute engines but still one source of data that you can access and have control over, that's like, the more I'm learning about Iceberg, the more that I'm seeing that. So I was just curious if anybody else is using it or would consider that an advantage over their current situation.
You talking about access through Snowflake or just accessing using Iceberg as is?
So accessing through Snowflake.
So the difference is Iceberg is standalone format. You can use it if you have a Spark cluster, you can just run your job against Iceberg directly.
Right.
The Snowflake Iceberg integration comes in that if you have your data in any other format than Iceberg sitting on S3, if you want to run the query from Snowflake accessing your data, first thing you have to do is import your data into Snowflake, run your query. Whereas Snowflake with Iceberg integration is you can create a virtual table from within Snowflake and call out without to do the explicit import.
Yeah.
And that's what the other two format doesn't do.
Okay, so you can have pointers from Snowflake.
Exactly, to Iceberg, as long as your destination is Iceberg.
And still maintain administrative control over your data.
Yeah.
Do you have a question?
I was just going to say that we use Snowflake currently, and using Iceberg in the future would be something that we're looking into.
What is driving the interest in looking into Iceberg?
The ability to have structured, semi-structured, and unstructured data and different projections of that data for different types of use cases. So my company does data health analytics. And so the data size and property is very heterogeneous. We may one day get a 3 million batch file of 3 million different requests, each with 1 megabyte of data. And we may also get a one-time request every quarter for 400 terabytes of data. So how do you optimize both use cases when you're going to get them in semi-frequently amounts? And turns out the answer is you don't. But if you want to actually say, but really I do want to actually optimize this, you really, really have to figure out how to disaggregate and pull apart all the different components of what we think of as a database. So normally a database is like the black box, you send in the SQL, you pull it out, and you get it back. Everyone's happy. But it's the SQL as the query turns into an abstract syntax tree, that turns into a plan, the plan turns into an intermediate format. That gets sent over through a wire protocol. That wire protocol goes to the database. The database then takes that query protocol, sends it over compute. That compute acts as a storage. That storage gets processed and sent back to you. And every single one of those steps now has a different open source project dedicated to making a uniform mesh that you can combine all these tools in. So you have Parquet evolving into the open source format of like Iceberg. And that is the next step of taking what you would call that storage layer and separating that out. And then the hardware evolution side, you've seen like S3 came out with a super high fast access layer, so you don't have to build that yourself with like glue and like crimes. So that's really cool, and you're going to see that more and more going on. So seeing that trend in the future, seeing where everything's going, and the fact that all these things are getting disaggregated, I'm going to start working our company towards a way where maybe we don't evolve out of Snowflake entirely, but setting things up so that we can take the best parts of the open source community and integrate them in a uniform way rather than having to rewrite everything over and over in order to have heterogeneous data in different places.
Well, good luck. That's going to be the idea of having different components handle different segments of the data processing layer. But then again, why I'm excited about Iceberg is it seems to not Holy Grail's a very high esteem, but like to have that ACID compliant but highly performant and fully controlled final destination for your data for analytics. It sounds like you're also seeing that as a way to an element of your future data stack or your data flow that is going to yield more results than just shoving everything in Snowflake.
Absolutely. It also makes future integration with other people easier. So like if in the healthcare system you might have a lot of very privacy conscious people, and one way to get them as a client is to say, well, you can keep your data over there, but you can still integrate with us, but that data has to be compatible somehow. So right now the data is compatible kind of if they have the exact same format and it's in the same location and it happens to be in an S3 bucket in the one AWS region that's like cost effective. Or in the future, you can actually have things that are cross compatible and you can just say, hey, if you put it in Iceberg, we'll just magically work with that. Or if you put it over here, we'll just magically work with that. Or there's a lot of potential in that.
If I could try to summarize my interest in I think of what you just talked about. So when you have HIPAA standards or GDPR standards, and or you need physical account separation of data, but still want to be able to have a consistent format that you can interact across companies, you can interact across departments. Iceberg as a standard allows for that. We know we can interact with your data, you can interact with our data, but we can also manage where the data sits so that it's in the most secure, compliant format. Is that?
It's part of it.
Okay.
There's the data storage, the data access to compute, and all of those things can be controlled in different contracts. So it's always going to be some sort of like a white glove handling situation. But generally, the trend we're moving towards is being able to integrate things that are both closed source and open source in different ways and not have to integrate more than you need. So like if a client only wants to give you data but doesn't want you to access it, that's possible. Or if a client wants you to allow someone else to give them access but you don't touch it, that's possible. And different weird combinations you would never think of, but lawyers are happy to invent.
It's interesting the conversation that you're having about this sounds to me like it's interesting the conversation that you're having. This sounds to me like the conversation that people are having around why Hadoop 10 years ago, why Kafka 5-6 years ago, like, wait, 10? I'm sorry, I'm old. It was 12 or 14. But like, thanks for bringing that up. That's really encouraging to hear that that kind of motion is still happening. And because anytime that a compelling platform comes along to provide us with good interfaces that we can standardize tools on that's not a closed platform, it feels like we benefit, because the stuff that Ben was talking about, you can give teams